Hello folks, welcome to a new video. So this is sort of a continuation from the last video itself, where we discussed about NAT and we mentioned forward proxy once in the whole thing. Like what forward proxy basically means is, one entity is representing some other entity or entities, that sort of a thing. So what we discussed was, in the outside world, these devices within a network would be represented by their gateway, and any requests on behalf of these devices will be sent by the gateway, and it would keep a record of where they send the request to in the NAT table, so that when they come back they can route it back to like the internet devices and stuff. So that we discussed, that's the purpose of the NAT table. And like I said, network address translation. So what is it's basically as simple as it sounds. It basically translates the address, sort of a thing. Basically, like when we receive it or when we send it, it would send from its own address. It would receive it on its own address, and it would again route it back to the internet devices based on this table. So that's what. So what it's doing here is basically it's translating the address of where the packet needs to go. That's what it's doing. So translation means basically if any response comes from, like, since D1 made a request to this address, so the NAT table is specifically saying that, okay, so if any response comes from this address, route it to this device in your network. So that flow is completed. So this is called forward proxy, like we discussed. Since everything is forward moving sort of a thing, it's moving forward, like forward as in multiple devices are represented by one entity, so it's moving forward. If you can imagine, like everything is moving towards that particular entity. What reverse proxy would mean is exactly the opposite. Like it would be coming from that particular device. Here things are going to the router, if you can see, to the outside world. But let's say this is a server, and let's say it's a very, it's a like a large number of requests come to this server. So what would be an ideal way to handle that? So let's say if we have one single entity of the server, it might not be very useful for us to like there is a lot of chance that this server might crash if the number of requests like increases exponentially more than it can handle. So what's the solution for that? One solution is increasing the capacity of the server. Like let's say we increase the CPU, we increase the RAM, we increase like the hardware and everything of the server and make it very bulky. That's one solution. Another solution is we make duplications of this server. Basically we make duplicate copies of the server and we have them somewhere, so that if one of them is getting a lot of load or getting a lot of pressure from the outside world, the others can take it up and balance out the load. So that's what basically load balancing means. Let's say if you are trying to design a very highly available sort of a system, then but you need, like, there may be a lot of number of active users and stuff, there may be a lot of number of requests coming in at once. There is a chance that your server might not be able to handle it and it might crash. So what's a proper way to do that would be to have the same entities of server running in multiple devices, so that let's say this is server 1, this is server 2, and this is server 3. Let's say there are 3 entities of the same server running. Let's say server 1 is facing a lot of requests and it's on a stage where, like, if any more comes up, then it might crash. Or so if imagine we didn't had these 2 devices, there is just one, let's say we didn't have any of this, there is just one server. If this crashes, then your site is down forever. Like no one can do anything about that. It's basically not fault tolerant, or basically it won't be able to handle anything after that until it's restarted. So within that period it would be down, basically. That's what it means. So for this kind of scenario, what's an option is we spin up multiple such servers, so that even if one is down, the other two are active, and we can have more of them, but for simplicity I'm keeping 3 of them as of now. And the same for all, like let's say S1 goes down, S2 and S3 are still up. So like if S1 cannot serve the request, S2 and S3 would do that, because ideally all 3 of them are doing the same thing. So this is the concept of load balancing, where we tend to like divide the overall load between however many servers we want, based on how much traffic we're expecting and stuff. So here, this is the load balancer. Here, this is the load balancer. Load balancer is in, like, as simple as it sounds. It's responsible for sending requests to the servers and stuff. It has some sort of algorithm, like basically it's responsible for deciding, let's say one request comes up, where it should send it. It's responsible for that. It can send it to S1, to S2 or S3 based on like several conditions and stuff. We won't go into that, but basically it's responsible for routing the request to one of the servers. That's all, based on some algorithm that it uses internally. So the basic task that load balancer is, you can think of, is delegation. Like it has let's say this is the manager sort of a thing. It has 3 employees. Let's say if you put on a lot of pressure on one employee itself, like they would burn out and they would just annoy and they would just like leave. That's what. So it's important for the work to be delegated among all of them. Like let's say employee 1 is doing a lot of work, so maybe you can delegate something to like employee 2 and employee 3 and keep the overall work balance, so that your work is also done and they also don't feel burnout and stuff. So that's the basic purpose of load balancer. And as you can see, like here we discussed. Okay, so let's take it ahead. So let's say now if we want to communicate with this server from this device, the same thing would come up. It will have a public IP, private IP, and so on, and whatever. Like let's say this is the public IP. So D1 will make a request. The router would check if it's in its own private network using subnet masking. Since it's not, it will make the request via its own public IP address, source IP, and it would store an entry of it in a net record. In the net record, it would store that, okay, if any response comes from this IP address, send it to this device, as in the D1. Like as you can see, these two addresses are the same. So basically what it's saying is, if any response comes from this, send it to this. That's all. Like NAT, they basically keeps track of that, as we discussed. And let's say this packet goes ahead to the load balancer. What the load balancer would do is, the load balancer would send this packet to any of the server. There are like concepts behind load balancing as well. You can do it in layer 4, layer 7, and like we'll come to that later. That's a bit advanced sort of a thing, but for now, let's say it's basic load balancing. It will send it to any one of S1, S2, S3 based on its algorithm and stuff, and it would get a response from that. And in the final packet, this would be, of course, like the source IP would be this one. Like let's say this load balancer is send it to S1. It would go to S1. S1 would process the data, send it back to load balancer, and we will talk about this connection. Like for some cases, this can be a different connection itself. This can be a different TCP connection with its own set of IP addresses, like source IP, destination IP, and that sort of thing, or it can be something else as well. We'll come to that. But for now, let's assume for simplicity, like that thing is handled. We don't need to worry about that. Basically, load balancer, it would send it over to some server. The server would fulfill the request and send it back to the load balancer. Now from here, the destination IP address would be the other one. Like since it's sending back to this router, this would be a destination IP address, and this would be the source IP address since it's coming from this load balancer. So yeah, that's the whole final packet that we need to send. It will come through, it will reach the router. The router will look up in a NAT table. Okay, so this request is coming from 158.158.1.2. Where do I need to send it? I need to send it in 192.168.1.2. Okay, So basically it will then send this basic it will basically send the payload over to D1, and D1 would get the response of whatever request was made, and it's done. That's what the whole flow is. Now if you notice here, like one thing is, it's the opposite of this, if you can imagine. Like what router was, in case of router, what we were doing was, we were sending requests to the router and router would make a request on our behalf. But here what we are doing is, the load balancer would receive the request and it would pass it on to the other devices. It's the opposite flow. For router it was coming to the entity, and for load balancer it was moving out of the entity, like shared entity, if you may. So this is a reverse proxy, if you can imagine. Like that's what it's called, since it's the opposite, basically the opposite. Like if you can imagine the arrows here, how would that look? How would they look? Like something is sent from here to here, here to here, and maybe here. I'll just move this IP as of now, just so that the diagram looks symmetric. So it's a like forward moving sort of a thing. Everything is moving towards the entity, but here the case is everything is moving, the direction of the arrow is away from the entity, if you can see. Basically the whole this would represent these three servers to the outside world, and whatever data it receives, it will pass it on to them. So it's also sort of a proxy, but it's the opposite of this. So it used to send, and it is consuming the data, and that sort of a thing. Basically, since it's the opposite, so it would be easy to remember if you call it like reverse proxy. Basically, this is the concept of reverse proxy. Anything that comes to the load balancer or any similar entity, it would pass it on to its private network, and like that would be handled there itself. Load balancer is a reverse proxy to handle the request and everything. If you have heard of Nginx and stuff, so those are like well-known node balancers and stuff. Sorry, not node balancers, load balancers. Okay, so yeah, that's basically that should be it, I guess, for reverse proxy, load balancer. Everything. So as we discussed, this is the whole, like how would it look like in the whole diagram. So it would look something like this, one whole flow. So this is probably how most of the applications that you use on a day-to-day level, they communicate, probably. Yeah, from your device to like wherever is intended to, back to your device on a very high level. So yeah, that should be it for this video, I guess. I hope it was helpful, and if you have any questions, of course you can ask in the comments, and if you like my content, of course you can like, comment, and subscribe and share it with your friends who might need it. And yeah, see you in the next video, guys. Bye.